Here I'm going to solve the trig equation cosine cubed x equals negative cosine x. So a technique for solving equations where we have x's on both sides of the equation is to actually bring the terms onto one side, and then we can attempt to factor from there. So I'm going to add this cosine x to both sides. That'll eliminate the cosine x on the right, and we're going to get all the cosine x's onto one side. It's a good technique because we could now try to factor, and we'll see if we can use the zero factor law in a situation like this to come to a solution. So since both the terms have a cosine x in them, let's bring that out front, and then we'll also divide, and this will factor the expression. At this point, because we have a multiplication of two factors, we can use the zero factor law. Zero factor law says that if you have one thing times another equaling 0, it says that at least one of those things must be 0. So I'm going to apply that here. We'll have that cosine x is 0, or cosine squared x plus 1 is 0. Now we'll try to solve by taking the cosine inverse. So start with cosine x is 0 and apply an arc cosine or inverse cosine to both sides. Now when we do cosine inverse of 0, you could think about the unit circle so angles that have a cosine of 0 would be pi over 2 and also 3 pi over 2. When you do a cosine inverse on calculator, though, it's only going to give you one of those answers. See, the range of arc cosine is only going to be from 0 to pi. So it's going to have to output an angle from 0 to pi. So if we do this on calculator, we're just going to get the solution pi over 2. Want to make sure you're in radian mode for this. And that is going to be pi over 2. So either pi over 2 or 3 pi over 2 could satisfy this equation. Now let's try solving for other solutions here. So here we should take a square root of both sides. But when we do, we have to acknowledge that we could have a plus or minus on one of the square roots. So this is going to be plus or minus I. So it looks like pi over 2 and 3 pi over 2 are the only possibilities that we have here. We should check them just to make sure that they check when it comes to the original equation. So I'll try plugging in the pi over 2. So a cosine of pi over 2 would be 0. So we have 0 cubed equals negative 0. That checks. And then we can try this one. So this also is 0. That checks as well. So these are the solutions. For further verification, we have the option of typing this equation into a graphing program. But what I'll do is I'll set the left side equal to y. Looks like Desmos doesn't understand that, so try it like this. Okay. There's cosine cubed of x. And then from the right side, we could do negative cos x. And what we're looking for is places where they intersect on the interval 0 to 2 pi. That's what the question asked for. So we do have an intersection here at pi over 2, also at 3 pi over 2. There's the end of the interval that they're asking for. They're only asking us to go up to 2 pi, so yeah, those are the only two solutions.